For the first one here, none of these are simple two-step equations. For the first one here, what do we see that we have to deal with before we start to solve it? That's exactly it. There's a variable on each side, so we have to get rid of one. We usually get rid of the smallest one. In this case, that'd be the 3x. And you're right. It's a positive 3x. We subtract it. It's gone. These are just 52 over there. We have to subtract it from both sides. That's correct as well. Where do we have to subtract it on the left side? From the 8x. Yes, we've got 5x and plus 7 equals 52. What's our next step? We subtract 7. So 5x equals 45. And then divide by 5. X equals 9. Number 2, where do we start? Well, the x appears twice again, but this time they're both on the same side, which means just can combine them. Now this is a 3x. We think of this as a negative 1x, which makes 2x. So 2x minus 9 equals 13. Then what do we do? Add 9 to both sides, so that gets rid of the minus 9. 2x equals 22, and then divide by 2. So x equals 11. Anybody have the first two right so far? Yeah, as long as there are other ways you can go about it. I mean, you don't have to follow those exact. Oh, well, that'll mess things up a bit. Number 3, what do we notice is different? We've got the parentheses, not necessarily FOIL, but distribute. Yeah, we have to multiply. So we do 5 times 7x, 35x. 5 times a negative 5, negative 25. And then we add 25. 35x equals 105, and then divide by 35. So x equals 3, correct. How about the next one over here? Here we would distribute the 2 or multiply the 2. 2 times 4x is 8x. 2 times 1. We still have the positive 12 there. Now what do we have to do? Combining the positive 2 and positive 12, which will make, perfect, 8x plus 14 equals 70. And then subtract 14, 8x equals 56. And then divide by 8, x equals 7. Now on all of these, if you're unsure, you could go back and plug the number in. Like here, I can put 3 in there for x. 7 times 3 is 21. 21 minus 5 is 16. 5 times 16 does give us 80. So you can always plug those numbers back in and make sure they work out. Make sure you get the same number on both sides of the equal sign. Well, the next step up might be to try something like this. I want you to try that and you know it's quick. I'll give you a... Okay, what's our first step? Perfect. Whenever we see parentheses, it should draw us there first. So we're going to do 5 times 3x, 15x, and 5 times 1 is 5. Now on this side, we still have the plus 7x. Let's go ahead and deal with combining or reducing this side. Careful. We got 15x and 7x here. Let's just combine them. So it's 22x plus 5. Now on the other side, there isn't anything to do quite yet. But we do now notice that there's an x on each side of the equation. We have to get rid of one. The smaller one is 5x. We're going to subtract 5x. So this is going to be 17x. Still have the positive 5. Over here, the 5x is gone, and we have 56. And then subtract 5. 17x equals 51. And divide by 17. X equals 3. Now, as I've stated before, we've got x equals 3. We can always come back up here and replace x with 3. So 3x becomes 3 times 3 plus 1 plus 7x becomes 7 times 3. 5x becomes 5 times 3. And now we can do our order of operations. 3 times 3 is 9. 9 plus 1 is 10. I can remove the parentheses. 5 times 10 is 50. 7 times 3 is 21. And that adds up to 71. On the other side over here, 5 times 3 is 15. 15 plus 56 is 71. We get the same value on both sides. So that tells us that we're relatively assured that x equals 3 is our correct answer. Give that one a shot. Okay, so we see parentheses. That should always draw us to do something there first. Since there's more than one set of parentheses, we'll work left to right. And we're going to stick to the left side of the equal sign first here. So on the left side, we got 7 times 2x, which is 14x. 7 times 5, 35. Then we still have the negative 4x. What can we combine there? Yeah, 14x and negative 4x make 10x. We still got the positive 35. That's all we can combine there. So let's go over to the right side. We have parentheses, so we will multiply 5 times 6x, 30x, and 5 times negative 3. Negative 15. We still got the positive 4. 30x has nothing to combine with. Negative 15 and positive 4 makes negative 11. Now, we see that there's an x on each side. We have to get rid of one. We'll get rid of the 10x is the smaller one. Leaves us with 35. We subtract 10x over here. We've got 20x minus 11. And then add 11. 46 equals 20x. And then divide by 20. So here we've got x. 46 divided by 20 can either be divided out to give you 2.3, or you can leave it as 46 over 20, which is 23 over 10, which is 2 3/10. Either way would be just fine. Well, to mess with you a little bit, try this one. Okay, the part on this one, the catch is, right before the parentheses there, what do we have? A minus sign, or negative. We have to think of that as a negative 1 times what's in the parentheses. So there's stuff in front of it, so we're going to leave. The 2x isn't going to change. But we have negative 1 times 5x is negative 5x. Negative 1 times negative 1 is positive 1. Now we can combine 2x and negative 5x makes negative 3x. And then subtract 1, negative 3x equals 15, and then divide by negative 3, x equals negative 5 is correct. Well, what changes if we have something like this? No, yeah, nothing changes. It's the same type of problem. We just have to deal with the fractions. This actually takes the exact same form as 5x minus 7 equals 32. Actually, 33 would work better. Over here, what do I have to do to solve this one? Sure, we add 7, and then we divide by the 5. We're going to do the exact same type of steps over here. It's just we're going to deal with fractions. What has to be added over here? We add 2.5. So 3/4 x is all that's left over here. 5 1/4 plus 2.5 would be 7 3/4. If you guys want to go through finding common denominators and add them, that's fine. You can use your calculators with the fraction function as well. I'm okay with that. Then what do we have to do? Divide by 3/4. Very good. So we've got x equals, this is 7 3/4, divided by 3/4. If we make it improper, 7 times 4 is 28, plus 3 is 31/4. This is going to be times 4 over 3. The 4's cross cancel. That's 31 over 3, which reduces to 10 1/3. X equals 10 1/3 is our result. You don't like fractions? Well, let's make you do some here then. To be fair, yeah, whatever. There you go, give that one a check. Where would we start on this problem? It's a positive, so we have to subtract it, yes. So we've got 2/3 x equals 4 and 5/8. Then what? Divide by 2/3. Very good. So x equals 4 and 5/8 divided by 2/3. That's probably right, but we'll go through the process. 4 times 8 is 32, plus 5 is 37 over 8. And this is going to be times 3 over 2. So we have 37 times 3, which is 111, correct? 8 times 2 is 16. 111 divided by 16 is 6 15/16. Correct? Perfect. So we can have 2.1x minus 1.5 equals 3.6. I'm going to let you guys try that one. What's our first step? Add 1.5. Very good. So we've got 2.1x equals 5.1. And then we divide by 2.1. X equals 2.428574143 approximately. round it to 2.43. That works. 2.43 works. Technically, it's 2 3/7. Did I ever show you guys how to take a repeating decimal like that and turn it into a fraction? Well, now would be a good time to do that. Let's say I have a repeating decimal like 5.33333. We don't make it repeating, just put that bar over it to indicate the 3 repeats forever and ever. We're going to let x equal 5.3 repeat. How many digits repeat there? All the 3s, yes. That's 1 digit that repeats over and over, right? Since 1 digit repeats, we're going to multiply by 10 on both sides. So x times 10 is 10x. 5.33, think of that as 5.333333, right? Multiplying by 10 just moves the decimal over once. That's 53.333333. Make sense? Now what I'm going to do is I'm going to subtract from this the 5.3 repeating. So the 3's, those all subtract out. Those cancel out. 53 minus 5 is 48. On this side, I'm going to subtract the 5.3 repeating as well, but 5.3 repeating equals x, so I'm just going to subtract x instead. It's the same thing. 10x minus x, we'll think of this, 10 minus 1 is 9x. So I'm going to divide by 9. X equals 48 over 9. Both those can divide by 3, so that's 16 over 3, so that's 5 1/3. So 5.33333333 is 5 1/3. Now most of you knew that 3 repeating was 1/3, right? Give me any 2 random digits. 27. So we're going to go 0.27 repeating. X equals 0.27 repeating. How many digits repeat here now? When it was 1 digit repeating, we multiplied by 10. When it's 2 digits repeating, multiply by 100. So x times 100 is 100x. Here again, you're thinking that's 0.272727, and moves it, multiplying by 100 moves the decimal point over 2 spots. So that's 27.27 repeating. And now once again, we're going to subtract the 0.27 repeating, so that just cancels out. All those repeating 27s cancel out. Now that was 0.27, so we're left with 27. Over here, we're going to subtract as well. Only 0.27 repeating equals x. So I'm just going to subtract x here. So it's 99x. 99x equals 0.27. I'm going to divide by 90, or equals 27, I should say. I'm going to divide by 99. X equals, both of those can be reduced by 3. That's 9 over 33. They can be divided by 3 again. It's 3 over 11. X is 3/11. So 0.27 repeating is 3/11. Let's go for a 6-digiter. What do you think I'm going to have to multiply both sides by here? Close. There's 6 digits, so there's got to be 6 zeros in my multiple here. So this is 1,000,000. X equals, well, the 1,000,000 moves the decimal point over 6 spots. So that's 142,857. 0.142857 repeating. Now, what am I going to subtract from each side? Bless you. Yes, I'm going to subtract the 0.142875 repeating, so that cancels out. It's 142,857 over here. Over here, well, that's just equal to x. I'm going to subtract x. Yep, 999,999. And then we divide by 999,999. X equals, well, let's see here. 1 plus 4 is 5, plus 2 is 7, plus 8 is 15, plus 5 is 20, plus 7 is 27. That divides by 9. Because the digits add up to 27, which is divisible by 9. So on bottom, that's 111,111. On top, let's see, that's 1, carry the 5, 5, carry the 7, 8, carry the 6, 7, carry the 2, 3, 15,873. Guess what? Is that divisible by 3? Yes, it is. So let's divide by 3. That is 5,291 over what? 37,037. What can they still be reduced by? What's that? So it's not divisible by 3. Why did I use 37 to try that top? Because 37,037, that's divisible by 37. That's just 1,001. 5,291 divided by 37 is 143. Guess what? Both of those are divisible by? 143. 143 divided by 143 is just 1. 1,001 divided by 143 is 7. Not your easiest reducing job out there. I'm not going to test you on the repeating decimal part of it yet. Okay, last Friday we left off. You were dealing with some pages like page 380, exercise 1410, 386, exercise 15.1, and 389, exercise 15.3. I want to make sure you've had some time to work on those and complete a good share of those. So that's going to continue to be our assignment for today.